Today we are going to talk about logarithmic functions. Your section 10.3, page 36. This is the one you are going to have a problem with, okay? In this class, you have two things you might have a problem. So one is the log function. Another one is the pattern recognitions, okay? So let's take a look. What are log functions? In 10.1, we talk about composite functions, right? Also talk about inverse functions. Then 10.2, we talk about exponential functions. Okay, so log functions are related to those subjects we talk about it. Okay, so let's see. What are logs? If you look at your calculators, you find out there is a button called log, right? If you see a log there, that means it must have some kind of meaning, so they put it in your put on your calculators. Okay, so let's take a look. When we talk about inverse functions, there are some criteria, right? Besides, it has to be a function, they also have to be what? 1-to-1, right? So, for example, if we talk about parabola, right? Parabola, let me make it bigger. So, for a parabola, it is a function. Yes, it is 1-to-1, each one. So, two numbers may map to the same y value, right? So, it's not a 1-to-1. So, when we do the functions, so when we do the inverse, let's see. I have two parts here, right? One is that, one is here. So if I do an inverse, what will happen? Right? So you will take a look. If you fold over for this curve, so this one would be reflect to this side, right? And this one will reflect to over here. So over this line. So this one will reflect like that, and this one will reflect like that, right? So from here, you can do inverse like there. And from this one, what do you do the inverse? So you flip over, so it will look like here. So from here, you will do the inverse like that, right? So for a parabola, it was this way. When you do the inverse, it will be like those, right? So for the inverse of this parabola function, what do you think? Is this a function? No, because you use a vertical line test, right? Why it is not a function? Because it was not 1-to-1. So if it's not 1-to-1, you cannot have an inverse function. Okay, so we need all those concepts to do our log. All right. So let's take a look. Then we are going to use exponential function to get our logs. Okay, let's see. So if I have start from exponential function, okay, we do the simple one, y equals 2 to the x power. So if we do our t-table, right, if we do our t-table, that will be y equals 2 to the x. Which number we put in the middle? We said 0, right? And 1 and 2, -1, -2. 2 to the 0 power is 1, 2, 4. 2 to the -1 power, reciprocal, right? Half and 1/4. We had this before. So 0 to 1, okay, 1 to 2, 2 to 4, and -1 to half, right, and -2 to the quarter. So that's our 2 to the x power, right? So for this one, is this 1 to 1 a function? Horizontal test for 1 to 1. So it is 1 to 1, yes. Okay, if it is 1 to 1 function, then we will have what? Inverse function, right? So it has an inverse function. Okay, and its inverse function is also 1 to 1, right? 1 to 1, you go back, still 1 to 1. Then will be reflect to, with respect to this line, you fold over, right? Because you switch x and y. This one is x equals y. So when we fold over, let's see how do they look like. Right? So let's take a look. So 0, 1 becomes what? 1, 0, right? 1, 2 becomes what? 2, 1. And 2, 4 becomes what? 4, 2. Right? And this one is what? -1 and half. Reverse over will be what? Half and -1. Half, -1, right? And this one will be what? A quarter and -2, like this. So your reverse, inverse will look like this. Okay, so we are talking about the inverse function of an exponential function. Okay, for example, for the y equals 2 to the x power. Okay, so you switch. So for the inverse, we do what? Switch. Okay, our x and y, right? Then let's see. If we do that, so it was what? Y equals 2 to the x. It was this one. Then when we switch over, right? When we switch x and y, what do we have? Okay, never mind this. Okay, we have x equals what? 2 to the y power. Is that right? If we switch from this one, x and y, it becomes this. So that means what? This blue line, blue curve, the inverse of an exponential function, it becomes this one, right? However, we always write what? We will always write a function as what? Y equals some x, right? We always write it this way, y equals something, y equals 2x squared minus 5, things like that. So we always get a y by itself, which is your f of x. So when we have this, x equals to y, we have to write y equals some x. How can we do that? But our y is at exponent position. How can we do that? So what we do is we write it this way, okay? We create a symbol called the log. That's a new symbol, okay? New symbol. And say, okay, my y would be what? With the base is 2, okay? If I do base is 2, my result is x. That's my y. So we invented this symbol as on your calculators for a purpose, okay? So you cannot see into the log. It doesn't make sense to you at all, right? What are those? So actually, log is just a symbol represent an idea for this curve, okay, which has the underlying meaning of this guy. So what does this mean? It doesn't mean much when you look at it, but it was what? We get it from here, right? X equals to y. It means y is on the exponential position for a base 2. It ends up, if you do 2 to the y power, it ends up, your result is x, is inside. Okay? So, we cannot see the log. What you need to do is, you need to translate the log to the exponent type of things. Exponential equation to see the log. Okay? Because we just use this new symbol to represent this idea. Okay? So, at the same time, you can see, what does log mean? Log means what? The inverse function of the exponential function. Okay, that's why we need to talk about inverse function. We need to talk about the exponential function to get to our log. Then how can you remember this log? So bottom one is the base, right? So you do the hook. If you hook this way, that means base hook to your exponent, then you get the result actually put inside the log. Okay? So we try to understand the meaning of the symbol for the log. That's what we try to do. But the idea is what? Log is this curve. Okay? So then we use the exponential function 2 to the x, then with the inverse function, the 1-to-1 function, to get the log function. Okay? I talked slowly. Hopefully you can relate. All right? So then we need to use composite function to check on them as well. Okay, so take a look at this one. In general, like this one, okay, and x equals 2 to the y power, right? So it means what? Instead of writing the 2, so I write maybe 3 to the y, basic 3 to the x power, or 4 to the x power. So if I have x equals b to the y power, right? Then we say when we use the base has to be bigger than 0. We don't use negative there. We don't use 1 there. Okay? And if we write y equals some x, we write what? Y equals log, right? Base with b, the result is x. So you do the hooking like this. They mean the what? The same thing. So we are talking about when you see the log this way, you will in turn thinking of what? B to the y power is x. B to the y power is x. Okay? Because we cannot think straight with the log symbol. Okay. At the same time, you can see this y, right? The log. Y is the log, right? So the logarithm is an exponent. Okay? So in turn, we represent the exponent y equals some x. Then that's your log function. And you look at it, so it is a function. At the same time, it is what? 1-to-1 function. So if 1-to-1 function, we will talk about domain and range. So for your test, if I ask you, describe what is an exponent function, you will say, okay, for exponent function, you will do what? F of x equals what? B to the x power. B is what? Bigger than 0. B is not equal to 1, right? Then if we ask you what is a log function, how would you describe? You will use the log symbol, right? So you will say f of x equals this guy, right? Log base what? B, as long as what? B is in such condition, right? So B is bigger than 0 and B is not equal to 1. So when it's bigger than 0, we have two conditions. We talk about that, right? Remember? So when the base, we had an example. It says, okay, for the log function, right? It can be f of x equals 2 to the x power or half to the x power, right? B is your base. Then this one, for this one, you can also write what? 2 to the negative x power. So this, for the second condition, this one is decay, this one is growth. Let's just talk about growth. For the base is bigger than 1, okay? So you have this condition, but let's talk about base is bigger than 1. Otherwise, it's not growth, it would be the decay. Then the inverse function is a little bit complicated, okay? Then let's just focus on the bigger than 1 situation like this, okay? So to talk about what is the domain, what is the range, as far as we can see. So what's your domain? Is what? Negative infinity to infinity, right? Oops, that's for exponent. Yeah, exponential function. Now we are talking about the log function. So we are talking about the inverse guy. Okay, so the inverse is what? What's your domain? So because this one is limited by this line, right? So domain is from up there, left and right. So it's from what? 0 to infinity. Then what is your range? How far you can go up and down? That would be negative infinity to infinity. Is this one-to-one function? Yes. Does it have inverse? Yes. Then we always talk about y-intercept and x-intercept, right? So what's your y-intercept? Here, none, right? What is your x-intercept? Here, the basic log function, okay? It's 1, 0. And does it have asymptote? So it's a little bit different from the exponential function. You have what? Horizontal asymptote. Then this one, you have a vertical asymptote. So how do you describe this line? The straight line goes through here. A vertical asymptote x is 0, right? Then what does that mean? It means it's bounded by, it approaches to the x equals 0, but never touches. Okay? So it means what? When the x, when the y getting closer to there, right? That means as y approaches to infinity, actually is what? Negative infinity, okay? Then x, it will close to 0. So that would be the difficulty for your pre-cal, and cal is the infinity concept, okay? Because it's very abstract for you to comprehend, okay? Doing it is not too bad, but underlying the meanings and the concepts sometimes it's not that obvious. Okay? So, let's look at some problems what we are going to deal with. Just typical. Okay? For exponential equations, you solve it. Same thing for log equations, we need to find the value, right, to solve it. So for your log, we say f of x equals what? Log function will be have a log, have a base, have x, right? So use the value, we don't use the f of x, we use y. You cannot see it, you have to in turn change them to write it this way. Base b to the y power is x. You hook it, right? So the y is only exponential position, okay? So you have, for a log functions, you have 3 positions. One is this guy, a number, one is the base, one is the value. So we want you to find, if I give you 2 values, you should be able to find another value. Or you can use, right, calculator. So if we have this situation, look at your page 37, okay? Let's get familiar with the symbols first. So if I have a log, I say log base 3 and 81 equals 40 equals 4. What does that mean? So we cannot see, we have to see it this way. If we change it, then we'll hook it. So we have what? 3 to the 4th power is 81, right? 3 to the 4th power is 81. But you can write either, you know, exponential style or log style. They mean the same thing. If I write a log base 2, 1/8 to the -3. So if you write it in the exponential style, what do you have? So you have 2 to the -3 is 1/8. Is that right? Reciprocal 1/2 to the 3rd power is 1/8. So they mean the same thing. If we have log 36 to the half, it means what? You hook it from the base, from bottom up, right? So 36 to half. What does half power mean? Doesn't mean half. Top is the power, right? The bottom is the root. So you have 36, take the square root, which is what? 36. So it's the same thing. That means that. Right? Another one is a little bit abstract. Log b bx equals x. You cannot see that, but if you change it to the exponent style, so you do this one, that means what? If I make base go through the hook for the power should equal to the inside. Are they the same? That means if I write a log 5 x, that would be what? X, right? Log 6 x, that would be x. Okay, so you have base and base kind of can cancel out, and then you get the exponent position. Okay, this is one of the property of the log that you will learn next time around. Okay, so we just show you the graphs, visualize it. So the log is the inverse of an exponent type of things, right? Then they are interchangeable by the symbol from the symbol side, like those. Okay, so mainly is you need to do that. Change the log back to the exponential equation, okay? So you have 3 numbers you need to be concerned about, and let's see. If we are going to change this one, we change the log back to exponent. How about change the exponent back to log? Okay, so, it's B. So 5 squared equals 25. If you write it in the log style, how would you do? Log base is what? 5. What do you put inside? What do you put outside? We say log actually is exponent, right? So you do 5 to the second power equals 25. That's how you write. Okay? So if you do 4 to the negative 2 equals 16, how do you write? You write a log base is what? 4, which is inside, which is outside. The value is inside. The exponent is the log. Okay? If you write a to the 1/3 equals 2, how do we write? Log base, right? Write the little one, don't write it too big. So, what's inside, what's outside? So you go through that. So that's 1/3. Result is 2. Then, how about b to the 0 is 1, right? Anything to the 0 power is 1, but the base, we don't use 0 either. So how do we write? Log base is b, right? Then, which one is inside, which one is outside? 0 outside, b to the 0 power is 1. So, what does this mean? It means what? If we give you a log value, say base 5, result is 1. What do you think the result is? 0 power. 5 to the 0 power is 1, right? If we say, okay, base 6 is 1, what is the value? It's 0. If we say 10 and 1, what's the value? 0. Okay? On your calculator, you have this symbol called log. Log means what? There is no base there. But for each log, we should have a base, right? That means it's invisible 10, default to 10. on your calculator. Your calculator doesn't have a 5, 6, or 7 as a base. It's a 10, okay? If you want to find the value of this, we have other way of doing it. So, another one is a little bit confusing as well. See, b base log bx, that's exponent, okay, equals x. How do we rewrite it? Okay, so if we rewrite this as a whole thing, like those, rewrite as a log, right? Then what's the base for this exponential equation? It's exponential equation, right? For this one. How should we rewrite it? So base is b, right? Then you hook your what? You hook your exponent, so log b of x. So you hook this guy, you're supposed to get this guy, x. Right? You rewrite this, end up this. Log b of x equals log b of x. Are they the same? Of course, they are the identical thing, but at the same time, we will rewrite it in the exponential style. You will end up this way. So what does that mean? So this is one of the property like this, okay, for the log. And if you have b log b, it kind of can cancel out x equals x. So if we have tried to find the value, say 5 log 5 of 7, what do you think the answer is? Cancel out, it's a 7. Okay, that's what this property is saying, right? So if I have 6 log 6, 7, it's what? 7. It doesn't make much sense to you right now until we do some more exercise and see some apps. You will make more sense to you, right? So what you need to do with the log basically is this one. Okay? And I had a student, he just missed this section, the basic concept of log. Then later on, he just had great difficulty to catch up all the operations. So you need to understand the basic concepts first before you can, manipulate them back and forth as subtract, multiply, and divide as such. Otherwise, you will be super confused. Okay? So this portion sounds okay. You can just follow through. But if you don't understand it, you will have great difficulty to, follow up. So then your situation will be like this. If I ask you log 4, 16, because this one is a value, then we say, what's the value? What do you think? Okay? We can just guess. What do you think the answer is? 4 to the what power is 16? So you just say, okay, it's 2. And done, right? That's fine. But if we have a situation like this, log 5, 125. Okay? You say, oh, 5 to the what power is 1 over 25. Oh, yeah. -2, right? 5 to the -2 power is that. It seems fine. However, when you have this one, it seems okay, but 1, 2, -1, -2. No. Okay, it's not that obvious anymore. So how should we do it? Systematically to help you to find the answer, right? Then we say, for the things we don't know, we use what? X. Okay, so if you use X, then you will change the log back to exponential equation. So what do? You write a 4 to the x power is 16, right? Then you will change because it becomes what? Exponential equation. Then you can solve it for x equals same base. Then your x is 2, right? Then for this one, we say, okay, it's a -2. But when you're actually doing it, if you don't see it right away, you put x here. Then you will rewrite this log back to what? Exponential equation becomes what? You hook it, 5 to the x power is 1/25. Then you change the same base, will be what? 5 to the x power equals what? 5 -2 power, right? Reciprocal. Then your x is -2. Okay? Especially if you cannot see it, put x there. Since you know how to solve exponential equation, it's more, vivid, right? Visualize. You can visualize better. So let's do this. So 9 to the x power is 1/3. Then how can you make the same base? Right? So you will use what? 3. So that would be 3. Okay, just write it below it so you can see, right? 3 to the square is 9. How about 1/3? Don't use 1/3 as base. Use the whole number if you can. All right, so instead of use 1/3, it's hard to maneuver for the 9. So you do what? 3. So what's the 3 to the power is 1/3? Reciprocal, right? So what do we have? Becomes what? 3 2x equals 3 -1. Then what do we have? 2x is a -1. Then your x will be -half. It will be easier that way. And here would be -1/2. It's really hard to guess, right? It's not as easier as the previous situation. All right, let's see. Next one. If you have log 6/3, okay, we talked about earlier on the top. All right, so we have what? Log b to the x power is what? X, right? So if you have this way, you can just cancel. It becomes 3. But if you forget about this, then what do? You say, okay, you can always use x to hold your answer, right? For the things you don't know. So what do? And you just change this to the exponential equation. So you do hook 6x to the 6/3. Right inside. Then what you'll have? X is 3. Right? Not too bad. Then how about this one? Log 8a to the 4th power. Now you know this. You can just say, okay, it's 4. Right? If you have log 9, cube root of 9 to do that, then it's hard to use the roots with log. So you always use what? The power style. Okay? So you will write it this way. Log 9, cube root is what? 1/3 power, right? Then you can just do that. Are we good? Okay. If we have those questions, log 2x equals 8. What do you think? We still use this. Change it to exponential style. So what do? You hook it. So 2 to the 8th power is x. So what do you have? So x would be 256, right? So you have 3 positions. One is the base, one is inside, one is outside. So like this one, inside you don't know, you can find it this way. Then if we have this one, 116 equals x, you might have 1, 2, 3 position outside you don't know. You still use the exponential equation to interpret, right? So what do? Hook it. So 4 to the x power is 116, right? Which is what? 4 to the -2 power. So then your x would be -2, right? That's how you find the x. So if we have this one, x 25 is 2. So you have 3 positions. Sometimes it asks you the middle, sometimes it asks you the result, sometimes it will ask you the base. What do? Same thing. X squared equals what? 25. Then your x is 5. We only use positive base. Remember, b is what? Bigger than 0, not equal to 1. Okay, so we just introduced the log functions, the basic concepts. So what do you think we will learn next time? The basic skills, right? Add, subtract, multiply, and divide, things like that. And some apps. Good? So this will be our section 10.3.